So, good afternoon, everybody. It is already 3 o'clock in Europe and in South Africa. So it's my great honor to start this special online workshop to celebrate the 60th anniversary of a famous paper by 3 authors. 2 of them will have a chance to greet soon. First, a technical remark. I would ask now all of you to mute yourself just to avoid any problems. And we can proceed. So this workshop is organized jointly by National Institute of Theoretical and Computational Science in South Africa and the Institute for Theoretical Physics in Kraków of the Jagiellonian University. Well, of course, the title of the workshop is Stochastic Dynamics of Quantum Mechanical Systems, exactly as it was the famous paper by Sudarshan, Mathews and Rau, written more than 60 years ago and published 60 years ago and half. And here you see the pictures of first late George Sudarshan and 2 other authors you'll have a chance to meet soon. This paper introduced so-called dynamical matrix, which is now used in the quantum information community very often. Let me briefly sketch the very key idea. So first, we discussed quantum dynamics in discrete time. So we take a density matrix and map it onto discrete, in a discrete time. So there is a matrix which we usually call a super operator, this huge matrix of size, let's say n square, which is neither Hermitian nor positive. And in this famous paper, they introduced so-called dynamical matrix just by reshuffling the indices. They call it B. And now in the modern notation, we just call it B is A reshuffled. And they provide in this paper properties of this matrix B, which is Hermitian, positive, semi-definite, and satisfies the trace preserving condition, which can be written as partial trace is proportional to identity. Let me only note that there are 2 equations with number 14, and both are very important for us. Well, only a few years later, Choi came with a nice observation and a strict mathematical theorem that if and only if this dynamical matrix B is positive or semi-positive, then the corresponding map is completely positive. But the notion of complete positivity was not established yet in the 60s. Later on, Professor Sudarshan got involved in other relevant studies on quantum dynamics in continuous time. So I will here mention 2 very important papers, one by Gorini, Kosakowski, and Sudarshan, published in 76, and then a parallel paper published by Göran Lindblad on the same topic. And perhaps you will recognize the famous equation, which is now called GKLS equation, sometimes also Lindblad equation, which governs the evolution of density matrix rho in continuous time. Here we have Hamiltonian dynamics, which leads to unitary evolution. And here this Lindblad-like part, which is related to non-unitary part. And here I found the known photo of 3 authors of this paper visiting Professor Ingarden, one of the founding fathers of the theory of quantum information, who was a professor of theoretical physics in Toruń at the Nikolai Copernicus University. So you could recognize late Professor Andrzej Kosakowski, George Sudarshan, and Vittorio Gorini. So there was a 48th symposium on mathematical physics, exactly 40 years after this paper, Gorini, Kosakowski, Lindblad, Sudarshan. And here you see the picture. Here you see Vittorio Gorini, and then late Andrzej Kosakowski and George Sudarshan. So it's our sad duty to emphasize that unfortunately 2 out of those 3 authors are not longer with us. So this,
but I saw that the recording.
This event took place on site in Toruń. Now we can only meet online. And now I welcome our guests of honor. So Professor Mathews and Professor Rau, two co-authors of the paper and members of the family of George Sudarshan, his wife and son. So this is end of our welcome remarks. Please enjoy the workshop. We start now and have the workshop till 7 p.m. European time. Tomorrow we'll meet at 11, but there will be a new link for tomorrow. Now we will proceed and we will ask our colleague from India to introduce the first guest of honor, Professor Mathews. So Vinayak, please go ahead.
Yes, thank you. Can you hear me?
Yes, please go.
Professor P.M. Mathews was born in Kerala, India in 1932, and he was a professor at the Madras University, India, and retired in 1992. He has worked on various topics in physics, including stochastic processes, quantum field theory, and geophysics, to name quite a few. And Professor Mathews was the recipient of the prestigious India's Meghnad Saha Award for Theoretical Sciences in 1975, and was also elected as a fellow of the Indian Academy of Sciences. A standard model of nutation was developed by Mathews, Buffett, and Herring, which is known as the MBH model. And in view of his contributions to geophysics, he was awarded the prestigious fellowship of the American Geophysical Union in 2004. So can I ask Professor Siniaski to start playing the recording?
Yes, please.
Just a second.
At the outset, I want to thank Dr. Vinayak Jagdish and other organizers of this workshop for inviting me to speak as a guest of honor at this conference convened to celebrate the 60th anniversary of the fundamental paper entitled Stochastic Dynamics of Quantum Mechanical Systems that I co-authored with George Sudarshan and Jayaseetha Rau and submitted for publication in 1960. I was asked to share memories of my research interests and of my association with Professor George Sudarshan. My interaction with Technical Chapter George, his given name appearing last, started in 1948 when he joined the Physics BSc Honours program at MCC, that is Madras Christian College, which retained its name even after Madras was renamed to Chennai. I was a year junior in the second and final year of an intermediate, that is pre-undergraduate program at MCC. A year later, I too joined the Physics BSc Honours program. George organized activities in physics and science in general. High-density balloons were being flown in the skies above by scientists from TIFR, that is the Tata Institute of Fundamental Research in Bombay, since renamed to Mumbai. George made contact with the scientists and got involved in their investigation. George completed a master's in 1 year at the University of Madras, and immediately upon graduation in 1952 was invited to join the TIFR. He was outstanding in any scientific work he undertook there. He worked with Homi Bhabha on cosmic ray showers. Paul Dirac, who taught Bhabha physics at Cambridge, gave lectures on quantum mechanics at TIFR in 1954. George and A.K. Gupta served as Dirac's scribes, preparing lecture notes. George married Lalita Rau in 1954, taking on the Hindu name Sudarshan. Professor George Robert Morshak of the University of Rochester, who studied under 1967 Nobel laureate Hans Bethe, and later became his PhD student starting in 1955. Having completed a postdoctoral fellowship at NRC in Ottawa, Canada in 1958, I continued as a postdoctoral fellow from 1958 to 1959 under Professor D.L. Falkov at Brandeis University in close proximity to Harvard University, where George Sudarshan, having completed his PhD in 1958, Professor Julian Stringer's research fellow. George's wife's sister, Jayaseetha Rau, was a physics PhD student at Brandeis, completing a dissertation in 1962 under Falkoff's supervision. The ensuing close contact between George, Jayaseetha and me gave us occasion to collaborate and author a paper together, the one this conference is about. George's subsequent work on the development of quantum correlations between parts of a large system led to the theory of stochastic semigroups, from which emerged the Życzkowski-Sudarshan equation that forms the basis for the study of large open systems. From 1969, George Sudarshan was a professor of physics at the University of Texas at Austin. By his invitation, I worked there as a resident scientist in 1982-83. Now I'll do an overview of my research. With my PhD advisor, Dr. Ladi Ramakrishnan, I published a paper in 1953 entitled Numerical Work on Fluctuation Problem of Electron Cascades on a class of stochastic integral differential equations and a stochastic problem relating to counters. One follow-on to these papers was a paper, Stochastic Equations for Non-Equilibrium Processes, that my fellow postdoc Erwin Shapiro and I co-authored with Dr. D.L. Falkoff at Brandeis University in 1959. I joined physics faculty of the University of Madras later in 1959. A brief break from research came soon after I became head of the Theoretical Physics Department in 1965, when Professor Falkoff honored me with a visit to India shortly before succumbing to terminal cancer. He co-authored a paper with Jayaseetha Rau, who had returned to India work at TAFR, and I took him on a tour of select places in India, including my home state of Kerala. To select from my publications numbering about 110, I published Localized States of a Dirac Particle in 1971, Arbitrary Spin Fields, Spectral Representation for Two-Point Functions, co-authored with M. Sitharaman in 1971, on the apparent visual forms of relativistically moving objects, co-authored with M. Lakshman in 1982, and on the admissible Lorentz group representations in uniqueness, co-authored with B. Vijayalakshmi and M. Shivakumar in 1982. Vijayalakshmi tragically died of terminal cancer before she could finish her dissertation. 13 other students I advised did complete their PhD. After retiring from my position as senior professor and department head at University of Madras in 1992, I was a visiting scientist at Harvard-Smithsonian CFA, that is the Center for Astrophysics, from 1992 to 1995. Afterward, I continued working there for several years during summers. At CFA, my field of research changed to geophysics. One of my publications was modeling of precession, new notation series for knowledge Earth and insights into the Earth's interior, co-authored with T.A. Herring and B.A. Buffett in 2002.
I think he's reading what he...
In 2004, AGU, the American Geophysical Union, honored me for developing the standard notation model by declaring me a fellow at a ceremony in Montreal with the citation saying, for extraordinary work in the theory of notation and the development of standard notation model adopted by the national scientific community. The model is named Mathews Buffett Herring model.
Rosa Mathews is there. I think its talk is recorded, I think.
Textbook of quantum mechanics,
him, he is just
cable
watching.
notation in 1976.
Recording the content.
And two, Precession Notation Wobble the Earth, co-authored with the Belgian Royal Observatory's director, Veronique Dahan, in 2015, published by the Cambridge University Press. I have worked as a visiting scientist at numerous research facilities around the world. Aside from the ones already mentioned, these include the International Center for Theoretical Physics in Trieste, Italy, the Nordic Institute for Theoretical Physics in Stockholm, CERN in Geneva, the Dublin Institute for Advanced Studies, the Paris Observatory, the Belgian Royal Observatory, MIT's Physics Department, University of Alberta at Edmonton, University of Hawaii, Osaka University, and Wuhan University. In conclusion, I would say that I have had a most fulfilling career in physics and that I am gratified at having been able to give this talk.
Thank you very much. And now I will ask Professor Mathews to greet us and, if possible, say a word to all of us. Please unmute. Ilya, could you unmute Professor Mathews? Yes, please, you are on.
Hello. I'm very happy that I got the opportunity to participate in this meeting. I thank the organizers, especially Dr. Jagdish, for inviting me to speak on this occasion. I'm glad to catch up with Jayaseetha after many years. It's a great that could see Sudarshan's family members here. I regret that George Sudarshan he passed away about a couple of years ago. So, thank you.
Thank you very much. Thank you for being with us and for your kind words. And now I will ask Vinayak to introduce the second speaker, also recorded. Vinayak.
Yes. Dr. Jayaseetha Rau got her master's degree in theoretical physics from the University of British Columbia in Canada, and then her doctorate in theoretical physics from Brandeis University in Massachusetts. Her PhD thesis was entitled Density Matrix, Formalism, and Theory of Relaxation Phenomena. From 1968 till 1993, she was a faculty at the Normandale Community College, Minnesota, teaching mathematics. Even after her retirement, she volunteered her time tutoring students in mathematics. Over to Professor Sinaski.
I would like to thank the organizers of today's workshop on the 60th anniversary of the fundamental paper on dynamical matrix to give a short talk and memories related to this paper. As I recall, George Sudarshan was at Harvard University, Professor Schwinger, working with Professor Schwinger. Mathews was at Brandeis, working with Professor Volkoff, and I was a graduate student of Professor Volkoff. We used to meet quite often and attend seminars at Harvard, MIT, and Brandeis, and also we used to discuss quantum statistics, stochastic processes, density matrices, and non-Hamiltonian dynamics, etc. The result is the above paper. I wrote my doctoral thesis as a continuation of the above work. The title is Relaxation Phenomena in Spins and Harmonic Oscillator Systems. I am very happy that this paper on dynamical mapping has got recognition, and workshop is organized inviting international physicists. I am looking forward to being an observer since I am not a practicing physicist. Thank you once again.
Thank you very much. And now, Dr. Rau, would you like to say a word to all of us? So, Ilya, could you unmute Professor Rau just to say hello? Sorry, not yet, not yet. You are still mute. We need to unmute your. I'm very sorry, we cannot hear you yet.
Yeah, I can only ask you to unmute. I'm asking you, you need to unmute on your side, please.
Sorry, I was thinking it can be done remotely. So we have to ask you, there will be on the left bottom side of the screen, there must be such a mute button, which will be now red. So please try to press it on the left, lower left edge of the screen. Lower left. Yes, yes, I think now you are on.
Yeah, I want to thank the organizers to give me an opportunity of kind of participating in a meeting, because I am not technically competent at the moment, because I have not done physics for a very long time. And so I'm enjoying meeting the people whom I have not seen for quite some time. Actually, Dr. Mathews and Dr. Shapiro, I used to see them 60 years ago. And then I think I've seen Mathews once or twice in the science meetings in India. And I am very, very happy that I have been invited to kind of participate in the meeting. I have been teaching in a community college mathematics, and that's all what I have been doing, and I'm out of touch with physics, even though I try to keep in touch, going through some of the synapses and things like that, because I still have interest in physics. And I'm actually very, very happy to see the workshop is organized and internationally known physicists are participating, and I wish them all the success, and also I wish them to continue contributing to physics. Thank you very much.
Thank you very much. Thank you for being with us. Now we proceed to the first speaker, also in video. So Vinayak will introduce the first speaker.
Yeah, Professor G. Bhamathi, wife of Professor George Sudarshan, was a professor at the Madras University, India, and also held affiliation at the University of Texas at Austin. She's a mathematical physicist working on various problems in scattering theory, quantum field theory, and particle physics. And she has co-authored quite a few interesting papers with Professor George Sudarshan as well. Over to Professor Sinaski.
Hey, ladies and gentlemen, at the outset, I wish to thank Dr. Vinayak Jagdish and his co-organizers for inviting me to participate in this two-day workshop. I've been asked to talk about George Sudarshan's legacy, and have been given a time slot of 10 minutes. Many of you will know that it is like trying to put the genie back into the bottle, but nevertheless, I have tried. I have listed the topics and areas in which he has made seminal contributions. It spans a time period of 6 decades and more. Slide, please. In the next slide. In 2006, a conference on Sudarshan's 7 science quests was held at Austin, and it brought out fairly comprehensively the progress made in the first 7 areas which are listed here. However, there have been many more developments not only in these 7, but also in a couple of others, much more than what it was then. And it's also possible many of you have also contributed to these developments. Sudarshan's contributions to the foundations of quantum mechanics and scattering theory have also been distributed over a period of 6 decades, while his contributions in the field of quantum computations as such have been only 2 decades. Next slide, please. In the next slide, I will elucidate briefly the main areas in which the seminal contributions have led to concomitant area of research. In weak interactions, his seminal contribution was the unified V-A theory with his mentor, Robert Marshak. And this has led to the electroweak unification of all the forces, and which in turn led to the standard model of Weinberg, Salam, and Glashow. Weinberg, as no doubt everyone knows, was given a Nobel Prize for that, but he declared in the conference in 2006 that the V-A theory was the key to his electroweak unification. Incidentally, the theory, V-A theory, was developed by Sudarshan when he was doing research for his PhD degree, and it formed a part of his thesis. Sudarshan's investigations on the role of symmetries in physics, they can be classified into 4 categories as listed here: classical dynamics, optics, particle physics, and quantum mechanics. Classical dynamics, summary of things would be to say it led to no interaction theorems, plus a reformulation of classical dynamics in terms of group theory. In optics, it led to Gaussian and Fourier-Maxwell optics and extended to electron optics. In particle physics, Sudarshan, Marshak, and Okubo got the first results on masses and magnetic moments sum rule for elementary particles for SU2 symmetry. After that was done, many more relationships were obtained for SU3, and the famous Gell-Mann-Okubo formula also resulted. In quantum mechanics, I've just briefly mentioned it as very phases, but many of the other developments in other fields also overlap with symmetries. The next topic in which he had made a fundamental contribution was spin in statistics. Here, Sudarshan had a very strong belief, which some people even call as religious belief, that spin in statistics, proof of spin statistics theorem did not need to be relativistic, but one should be able to prove it even non-relativistically, which of course he did in 1963. And much later, he also gave an extension to higher dimensions with his collaborator, Boya. Another person whose fundamental contribution, which was color symmetry by Hahn and Nambu, was motivated by the spin statistics theorem and basically the spin statistical relation that all particles or multi-particle systems must obey overall fermion or boson statistics depending on the collection of particles. I will jump over the quantum coherence optics for the moment and talk about tachyons. Tachyons are particles which travel faster than light. Sudarshan had thought about this much earlier than anyone else. And in some sense, many people describe his attitude to physics as an iconoclast. And this one exemplifies it in the sense that he did not hesitate to overthrow conventional vision if a fresh approach and a thorough investigation warranted it. It was this spirit which led him to show that particles traveling faster than light did not violate any laws of physics. However, by the very nature of tachyons, it is not possible to produce them in the lab, and therefore there are not many experiments or any further research on that through physical means. But there have been experiments which have shown that in tunneling, the effect seems to be precede the cause, so to speak. But tachyons probably have contributed much more to science fiction. So we go back to quantum coherence optics. In this, of course, it's now well established that Sudarshan's diagonal representation was the first and correct theory to lay the foundation for the entire field of quantum optics. It has led to, it was proved by the observation of the anti-bunching of photons and sub-Poisson photon statistics. It also led to squeeze states, quantum teleportation, and various other developments, which also relate to the subsequent topics which we talk about. The next one is the fundamental thing came in 1977 when Sudarshan proposed with Mishra the quantum Zeno effect. And this again has led to an array of, a vast array of research topics, such as decoherence, dissipation, quantum information, quantum technologies, quantum control, and probably many more. I will not touch too much upon these, nor on the following category, open systems, because many of you are probably already working in these fields, and I would probably be carrying coals to Newcastle. As far as open systems are concerned, the very basis for this workshop has been the original paper of Sudarshan, Mathews and Rau on open quantum systems. And all of you, and subsequently, about 15 years later, the development of the Gorini-Życzkowski-Sudarshan equation, also simultaneously done by Lindblad, has now led to so many new developments and branched out into various other things, which will probably form the subject matter of this entire conference. Next slide, please. So these are some of the lesser known areas in which Sudarshan's contributions have been. Tomography in particular, of course, now I think a lot more it has been a burgeoning field, and Sudarshan and his collaborators, mostly from Italy and Spain, have continued to make tremendous progress and made substantial contributions, which are related to entanglement with witness states and various other things. Here, I think I may say a particular fact, which is probably not familiar to most people, is that Sudarshan's first foray into tomography came from an industrial application. And that would be very surprising from Sudarshan, but it turned out that he helped develop what are called the CETA systems, computerized industrial tomographic analyzers. He did that with a couple of colleagues in the physics department at UT, in particular, Professor Lon Morgan. They even got a patent for it. But of course, the reason why this whole problem caught his attention and interest, as may be expected, is from the presence of the radon transform, which of course now in tomography and physics that is being used fully. Sudarshan's contributions to the foundations of quantum mechanics have been distributed again over a period of at least 5 decades. In the last 10 or 15 years of his life, he had revisited some of these problems. And one of them is time operator, as time as a dynamical operator, uncertainty relations for multimode states, CPT theorem, and the relationship between CPT and spin statistics. He also had a few problems solved in scattering theory. And the most recent things he was involved in was in quantum computation. I was fortunate to collaborate with him on a few of these later investigations, in particular in the development of cascade model in scattering theory. In scattering theory, he was not very happy with the way the asymptotic scattering states and the problems dealt with them turned out to be because of all the infinities and the way the infinities were gotten rid of. He personally felt that a solvable model would probably throw much more light on those aspects where it can be used. So he had used extensive use of Friedrich Lee model to study many problems, including some even in quantum Zeno effect. But we applied an extended Friedrich Lee model for multi-step processes in building the cascade model. Then it was found that it's possible to arrange it not only for decays of multi-step decays, but also for rearrangement collision processes. So in quantum computation, of course, he did not have much time to contribute too much but he had been working with people who were doing quantum computation. So I finally come to talk about his legacy. The next slide, please. I would say, in summarizing, I would say that I tend to look at his legacy more from the perspective and his motivations rather than from what followed after his seminal contributions. And the spirit, the legacy of spirit that he has left behind is open-mindedness in the pursuit of knowledge, a thorough investigation based on unbiased analysis, and conclusions based on the results of logical deductions. Finally, his spirit has been to pursue one's vocation irrespective of rewards, and the pursuit and the knowledge gained are in themselves the rewards. Finally, no discussion about George. His contributions will be complete without a quotation or a recitation of a Sanskrit verse, which he was very fond of. This verse exemplifies, in a sense, the complete circle of his quest. If in physics, his quest can be described as from being to becoming, the circle was completed in his philosophical quest from becoming back to being. And here goes the poem that he was very fond of. Vishwam datpanamanan tatpana drishyamana nagari tulyam nijantargatam pashyannatmani mayaya bahiribodbhutam yatha nidraya yas sakshat kurute prabodha samaye swatmanameva vadvayam tasmai shri guru murtaye namayidam Shri Dakshinamurtaye. Thank you.
Thank you very much. I'm very much impressed by the presentation at the very end. And now, would you like to say a few words and greet the audience? So please try to unmute yourself.
Yes, I think I have. Can you hear me?
Yes, please. Yes, thank you.
I wish to repeat my thanks to the organizers of this workshop for asking me to participate in it. And initially, I was not very sure about what was the role I was expected to play, in a sense, because in this particular paper, which is the central topic of the workshop, I had not collaborated with him, not even in further ramifications of that. But nevertheless, the organizers asked me to say something about his legacy, and which you have, of course, heard me present. I also wish to add, saying that even though I'm listed as family, I was also, I had known him long before I became family. I had known him from my PhD days, and I've been tremendously motivated and had great admiration for his work. And my association with him as a physicist and a colleague has been as a student from 1962, and then as a faculty member at the University of Madras. I was also an associate member of the University of Madras. I was a professor there for several years, and Professor Mathews was the head of the department, and we had been colleagues for the longest time. And I had known also George Sudarshan as a colleague for many, many years. So I decided also to take the role of being a physicist rather than family. And I hope it's okay with the conference organizer.
Thank you very much. It was great.
I have really enjoyed being here, and also kind of being at least be able to see many of my old colleagues and friends. And I thank everyone for giving me a patient audience. Thank you.
Thank you very much. And thank you for letting us know about the legacy and all the achievements of George. And now I will ask our last guest of honor, Ashok Sudarshan, to say a few words to us.
Thank you, Professor Życzkowski, and also to the organizing committee, Professor Petruccioni and Dr. Jagdish. I really appreciate the opportunity to address the group here. I also want to thank the Institute of Theoretical Physics and the National Institute for Theoretical and Computational Sciences. My dad sadly never had an opportunity to go and travel in Africa, although he deeply wanted to, but he had a deep love affair with Poland, starting with traveling in the 1970s there, and always bringing home bullgrass vodka. And then, of course, much more recently, spending time in Torun, where he was enjoying himself and would regale me with stories of getting to eat wonderful meals while he was there. So he made me quite jealous. So hopefully one day I'll get an opportunity to go there and make a little bit of a pilgrimage and see some of your beautiful country. I think I'll just start off by saying I'm certainly the least qualified person on this call to participate in any way, shape, or form. I don't know anything about physics, and I'm sure my dad would be the first person to tell you guys that I'm not qualified in that department. So I won't comment on the physics at all. I will say, however, it is deeply a family business. I don't think many of you know, but in addition to Dr. Bhamathi, Dr. Rau, who's now Dr. Premanand, is my aunt. My uncle, Dr. Rau, is actually going to speak a little bit later. My cousin, Dr. Atul Simha, is also on this call right now. And my aunt's husband, the other Dr. Premanand, who sadly passed away a few years ago, was also a physicist. So everybody in the family is a physicist except for me. And so again, as I say, I'm certainly not qualified for this. My dad had many things that he loved in life. He certainly loved physics and the exploration of knowledge. He was vehement about the fact that he was a scientist and not just a technician. He loved the relationships that he developed a long time. And I think the group of people who are on this call are all folks who knew him or knew of him and knew of his love of the brethren that worked in the scientific community. And I think on top of that, he loved travel and he loved food. And so all of those things kind of come together whenever I see and spend time with people who understood his legacy. The last thing I just wanted to make sure of was my dad was adamant about the fact that people who did the work should get the credit. And so I want to make sure that Dr. Mathews and Dr. Premanand, they're both recognized as equal co-authors of the paper. In many occasions, I think things happen in the scientific community where other people are attributed work or given more of the credit. My dad was never that way. He was a big believer that you should share both the responsibility as well as the credit for the work. And so I know as he sits and participates in this particular conference from the sky, and as I can assure you is paying great attention to what's going on here on this conference, he would want to make sure that the focus was not on him, but was on the work that he did with these two co-authors and the fact that they're here to present on my behalf. So thank you all very much for indulging me in just a moment of remembering my dad. I know my dad would be thrilled that this conference is going on and that's something that was done 60 years ago. Although he was a tremendously impatient man as a father with me doing my homework, he was an incredibly patient man, knowing that work that he had done 50, 60, 40 years ago would eventually become something that other people would hope to talk about. I appreciate the time. Thank you.
Thank you very much. I can only assure you, you are welcome in Poland or in Kraków or in Torun. Thank you for your words. So
thank you.
Let me thank all of you, all guests of honor, and now we basically start to work. So, yes?
Ashok do?
Yes, yes. Hello, thank you. Thank you.
No, he's not a physicist, but what is he?
Okay, so Ashok?
I work in on the business side in an insurance company here. We provide services to older Americans.
I see, I see. So it is like applied mathematics, financial mathematics in some sense.
That's exactly right. Financial
So you also
engineering.
use statistics or statistical physics almost.
That's
Thanks.
right. That is right.
Thanks for letting us know. Thanks, Ewin, for a good question.